Okay, get this. Hidden deep under the ocean, spread across the entire seafloor, there's a secret code. It's a message that was written in rock millions of years ago. And once we figured out how to crack it, it completely changed how we see our own planet. So you ready to play detective and dive in?
So here's our central mystery. Scientists discovered that the seafloor is covered in these huge, invisible stripes. It's like a giant barcode for the planet, with alternating magnetic signals. The question is, what in the world created this pattern, and what story are these stripes trying to tell us?
Now, to figure out what's happening on the surface, our first clue, well, it isn't on the surface at all. We have to take a journey thousands of kilometers down, right into the heart of the Earth, because that's where this story really begins. Welcome to the planet's engine room. Deep inside, you have a solid inner core, but around that is a churning, swirling ocean of molten iron and nickel. That's the outer core. And all of that motion, all that sloshing liquid metal, generates a massive, powerful magnetic field that surrounds our whole planet. And that's what we call the geomagnetic field. You can think of it as an invisible force field that protects us from nasty solar radiation. But for our detective story, its most important job is much, much simpler. It's the reason a compass needle points north. And that little fact, that's the ink our planet uses to write its own history.
Okay, now here's where the story takes a wild turn. You probably think that north is, always north. It feels like a permanent fact of life. But what if I told you it hasn't always been that way? Turns out, Earth's magnetic field has a pretty dramatic secret.
So on the left, that's what we call normal polarity. It's what we have right now. Your compass points north, no big deal. But look at the image on the right. At many points in Earth's history, the entire field has flipped upside down into reversed polarity. And yeah, you guessed it, if you were around back then, your compass would point south. How crazy is that? This is the huge plot twist in our story.
So, we have a magnetic field that flips, but how does that create stripes on the ocean floor, right? Well, the answer is at the mid-ocean ridges. You got to think of them as these giant, incredibly slow-moving tape recorders that have been documenting every single one of these flips for millions of years.
Let's break down how this tape recorder actually works. So, at a mid-ocean ridge, you have hot magma rising up to the surface. As that molten rock cools and hardens, tiny magnetic minerals inside it act just like microscopic compass needles. They all line up with the Earth's magnetic field and then get locked in place. So boom, this new rock has just recorded a normal polarity.
All right, now let's jump forward in time. Whoops, the Earth's magnetic field just flipped. New magma is still rising up, but this time, when it cools, all those little mineral compasses lock in pointing south, recording the new reverse polarity. And that older rock we saw before? It gets pushed out to the sides. You can start to see the pattern forming, can't you?
Now just imagine this process repeating over and over and over again for millions of years. The field flips back and forth, new rock forms at the center, and the seafloor just keeps spreading outwards. The result is this incredible, perfectly symmetrical pattern of magnetic stripes on either side of the ridge. It's a beautiful mirror image, a complete recording of our planet's magnetic history. Okay, so we've got all our clues in place. We have a magnetic field that does backflips, and we have a seafloor that's acting like a tape recorder. I think it's finally time to put it all together and solve this thing.
And here it is, the big reveal. Those invisible stripes aren't just a random pattern at all. They are a physical timeline, a literal history book written in rock. Each stripe represents a chapter in Earth's story, a specific period of time when the magnetic field was either normal or reversed. And this is the real game changer. Because we can figure out when those magnetic flips happened, we can use the stripes to actually tell the age of the ocean floor itself. It's incredible. The youngest, newest rock is always right there at the center of the ridge. And the further you move away from it, the older the rock gets. We're literally looking at a map of time.
This discovery was absolutely massive. It was the key piece of evidence that proved the theory of plate tectonics, changing geology forever. It showed us that our planet's surface is in constant dynamic motion, and it really makes you wonder, if the ocean floor is a history book written in magnetic ink, what other unbelievable stories are still down there, just waiting for us to read them?